Welcome back, everybody. Monty, Geometry, Shadle Park, week 15. Wow, we're halfway through the month of January. Amazing, and it's 40 degrees outside. So January 11th to the 15th, okay? We are now in Module 2, Topic 1, Lesson 2 of congruence, okay? This is equal to this. Boom. It was a reflection. We could have proved it. We could have measured it, all right? But before we get into all this math, we got to do our shout outs for last week. Let's see who did extra work last week. So, it's shout out time. And we want to do our extra achievers, the folks that did extra things to make class special. Those are the people that show their video, right? They turn their cameras on. They ask special questions to keep me from making mistakes. Those are the things that we want to honor. So here we go. In period 4, Isabel Bennett, Hunter Lawson, Colin McBride, Riley Morgan, Jackson Knoll, Cam Odell, and Logan Powers. This last week in period 4, each of those folks said things and did things that made our class better. All right, let's go to period 5. Kristen Barnett, Alyssa Granados, Carter Harris, Maya Eckel, Arthur Lucan, Matt McConnell, Carlene Nolan, Jackson Rookdy, and Teddy Weston. Again, thank you for all those things that you do to make our virtual classroom better. Thank you. Now, let's do our Mathia Achievers. Now, remember, the entire month of January, I'm expecting 2 different sessions on Mathia, okay? And here's the folks that went over and above. Isabel Bennett, Alexis Brandt, Emma Contois, Theo Gepetti, Gabe Giroux, Colin McBride, Quinn Moses, Jackson Knoll, and Cam Odell. Thank you, period 4, for going extra over and above on Mathia. And on period 5, Kristen Barnett, Spencer Deerdorf, Maya Eckel, Alyssa Granados, Kylie Eckel, Arthur Lucan, Matt McConnell, Carlene Nolan, Ashley Ohl, and Jackson Rookdy. Those are our shout outs for last week. See if you can do something to do extra this week so that you're on the shout outs for next week. Okay, our learning. If you watched last week's video, I told you it was Discovery Week. Okay, do our little Indiana Jones thing. This week, we're not only talking about congruence, but we're talking about 2 shapes. Okay, my 2 hands, they're equal. How do we know they're equal? Okay, we can put them side by side. Okay, so some sort of a reflection, right? Or remember how we would slide? We would do those transformations. We want to go further now. Okay, and I'm going to just show you a really popular triangle, the 3, 4, 5 triangle. Okay, now a 3, 4, 5 triangle, if we were to reflect it, we want to be able to find all of the corresponding parts. Do you see how A corresponds to D? B corresponds to E, C corresponds to F. So this week in class, we've got to practice that. We have to be able to identify, 1, the order, okay? So these triangles, what corresponds to what? The small angle to the small angle. So angle A corresponds to angle D. B and E, C and F, okay? So we're going to spend time writing that this week, okay? All right. Now, in addition to that, we want to know what segment. The 3 is equal to the 3. We need to be able to write that segment BC is congruent to segment EF. Okay? So we're going to practice writing this notation. It takes time. And in addition to that, we got this new term, the CPCTC, the corresponding parts of corresponding triangles are congruent. So let's use an example, okay? If you remember back, I would take these shapes and I would cut them, right? We would bend them and we would fold them and we would talk about, are they the same? You see how the black angle goes to the black angle? That the blue angle and the blue angle go together, the red angle and the red angle? Well, we have to do the same thing with the sides. This side here goes to this side here. The CPCTC, the corresponding parts of corresponding triangles are congruent. All right, so that's what we're going to be working on this week. So practice it. Takes a little bit of time because there's 3 angles, 3 sides. Now, I call this Discovery Week for the following reason. Did you know that if you take this length, and this length, for instance, the 3, 4, 5, do you know that there's only one triangle in the whole world that looks like that? I'm serious. There is. If you take a 3-inch straw, a 4-inch straw, and a 5-inch straw, and you put it together, there's only one triangle like it. And that's called the side, side, side rule. Serious. Now, what if I took a side, a specific angle like this one here, and another side? Do you know that if you took a side, an angle, and a side, measured it exactly, and put it on paper, there's only one triangle in the whole world that looks like that? I'm serious. That's called the side, angle, side rule. And then next week we're going to try angle, side, angle, and angle, angle, side. Seriously, it's Discovery Week. Now, with the distance learning, I do apologize. Because in class, we would actually do this with straws and marshmallows. I call it the marshmallow activity. It's awesome and it's fun. And by the time you leave class that week, you realize side, side, side works. If you have a 3, 4, 5, there's only one triangle in the whole world. Everybody in class tries it different and they all come up with the same. Serious. Then the side, angle, side, angle, side, angle, and angle, angle, side. So in the distance learning world, virtually, we're going to try to come up with our own marshmallow and straw activity. So until then, keep triangles in the forefront of your brain because we're going to be looking at them a lot the next 2 weeks. See you on Tuesday.